Hello students, in this lesson let us discuss some more tests on aggregate. So these are the final 3 tests which we have to discuss on the aggregates. So starting with the first one, I have named number 11 here because starting from the last 3 lessons we have been dealing with the tests on aggregates. So this is the 11th test, which is the aggregate impact value test. Now before getting into the test, you have to understand what is the aggregate impact value. This is nothing but it is generally the relative measure of the resistance of an aggregate either to a sudden shock or impact. See, for some aggregates, this is nothing but the resistance to a slow compressive load also, okay? But for very, very few aggregates. Right, now what we do in this is we take the total sample, what we take should have aggregates which are passing the 12.5 mm sieve and which are retained on the 10 mm sieve. Now once you take this, you have to oven dry them at a temperature of 100 to 110 degree centigrade and then cool it down. Now what will you do after this in this test is take the impact vessel. Okay, so in this vessel what you have to do is first you have to fill 1/3 of the portion from with the aggregates what you have taken here. Okay, 1/3 full. Then you have to tamp it for 25 times using the tamping rod. Make sure you're tamping throughout in all the places where you have filled. Then what you have to do for the second time, now completely fill the, this is first time, right? 1/3 fill. In the second time, you will completely fill the vessel and then tamp it for again 25 times. Okay, completely you have to fill. Now for the third time, you have to little overflow. So because after the second time completely filled you have tamped, there will be certain more amount of space which will come. So in order to fill that also, you have to overflow the vessel and then again tamp it for 25 times. So basically you are doing it how many times? 3 times. And whatever is the extra amount, you have to just remove it off with the edge of the tamping rod. Okay. Now you take the net weight of this particular aggregate. So this is what net weight of aggregate. Okay, consider this in grams and call this net weight as weight A or WA. Now this is this entire thing is your step 1. Okay, now you have to go to the step 2. Now what you'll do is you'll take a cup which is of 120 mm internal dia. DI I will write. This is nothing but internal dia and this should be 50 mm deep, or the height of this cup should be 50 mm. You will fix this to the base of the machine. Say suppose this is the base of the machine, you will fix this cup here, right? And in this cup you will place the whole sample or put the whole sample what you have measured in this, right? You'll put it, pour it and again tamp it for 25 times using the tamping rod. So here once you do this second step, next is your step 3. Now what you will do is you'll take the hammer of this particular equipment for an height of about 380 mm from the face of the aggregate. Okay, so this height from here to here, say this is your hammer, so this height should be 380 mm. Now from here you will make the hammer to freely fall on the aggregate. Now how many falls you will give? You will give around 15 blows or falls. So basically you are applying a sudden shock or impact on the aggregates, right? And this blow you have to make sure that should be less than 1 second time. So remove it, blow it, remove it, blow it. You cannot have more than 1 second time. Okay, after you do this, what you have to do? You have to remove all the crushed aggregates from the cup. Okay, so now after this impact has happened, the aggregates in this cup might have crushed, right? So you have to remove them. And once you remove, you have to sieve it through IS 2.36 mm sieve. Okay, so totally sieve it until a point that even after sieving for 1 minute, there is no aggregate particles which are coming down from this sieve. So till that particular portion, you have to sieve it. Understood? So that is your step 4. Now, after you do this, so we have weight A here. You remember the net weight of the aggregates in this particular vessel, right? Now you will have to measure few more things. What are the things you have to measure is the fraction of the particles which have passed through that sieve of 2.36 mm, that you have to measure. Okay, fraction passing the sieve. To You should not get confused, so I'll just write it. Passing the sieve 2.36 mm. So this we will call as the weight B or WB. Now generally you have to maintain an accuracy of about 0.1 grams when you are measuring this, right? Once you do this, you have to next measure the fraction which is retained on this sieve, okay, and name this as your weight C or WC. Now what will be the total weight? Obviously the total weight will be weight of B plus weight of C, that is WB plus WC. Generally this will be less than your initial weight, which is nothing but WA. Okay, but this less than should not be more than 1 gram. If there is a difference of more than 1 gram which is coming, then you might have lost some of your aggregates while doing the test somewhere else. So you have to discard the entire test and come up with a fresh test. Okay, so generally this process you have to repeat for 2 times or take it 2 tests. So test 1 and then test 2. 2 times you have to do this test separately individually. Now once you do this, the aggregate impact value is found using the formula capital B by A into 100. Okay, where what is B and what is A, I have already mentioned. So weight of fractions passing 2.36 mm sieve. This is weight of oven dried sample. Generally, the ratio of weight of fines formed to the total sample weight in each test are expressed in the form of percentage, and then we record it into the first decimal place. That is how you'll get the total aggregate impact value. Okay, moving on to the next test, it is the aggregate abrasion value test. This is generally done on the coarse aggregate, and it is done in 2 machines. First one is using the Devil machine and the second one is using the Los Angeles machine. So first we'll discuss the first bit using the Dewell's machine. Now in this, first we have to understand what is the abrasive charge we use. So this abrasive charge will generally consist of 6 cast irons or steel spears, cast iron or steel spears. Now these diameter of these spears are generally approximately equal to 48 in dia, and each of them will generally weigh, I'll write each because one ball will generally weigh around 390 to 445 grams. Okay, so how many we have to use? So the total weight of these 6 charges will be approximately equal to 2500 plus or minus 10 grams. For each test we have to use this. If we do number of tests, for each test this is how much is the total weight of the abrasive charges. Okay, so that is your first bit of the test you have to consider. Then generally this test will consist of the dry coarse aggregate, which are in varying sizes. Okay, so the percentage of the various sizes are given in this particular table. You can see here. So this is how we have to follow the grading and do it. So generally if it is grade A, so these are the passing sieve numbers, these are the retained sieve numbers, and this is the percentage of sample we should consider. So for all four we have to take 25%, 25%, 25%. Suppose you are going for grade A work, suppose you are going for grade B work and you are testing for grade B, you have three things here, so 25, 25 and 50. You're going for C, you have 2, 20, 25. This is passing sieve, this is retained sieve, and generally 50%, 50%. For grade D, these two, and for grade E, these two. Okay, so it depends on for which grade you are considering the test. That is very important. Okay, now the weight of the test samples will generally depend upon the range of the specific gravity which is given. How much of test samples you should consider? This is a different one. This is for abrasive charges. This is for the aggregates or the test sample. How much sample you have to take? So if the specific gravity of that aggregate is over 2.8, you have to go for 5500 grams. If it is between 2.4 to 2.8, you have to take 5000. Between 2.2 to 2.39, you have to take 4500, and if it is less than 2.2, you have to go for 4000. Okay, so these are all the details about what are the abrasive charges you are going to take and what are the weight of the test samples you are going to take. Now let us discuss what is the exact procedure we follow when we are conducting this particular test. What we will do is both the samples we choose as well as the abrasive charges will be taken together. Okay, and we will place it in the Dewell abrasion testing machine. Now we have to rotate this machine at 1000 revolutions, and the speed you have to maintain is somewhere around 30 to 33 revolutions per minute. So until you complete your 1000 revolutions, you have to do it. Now once this is completed, you have to stop it, remove the sample and the abrasive charges. Okay, and pass the sample via a 1.70 IS sieve. Once you pass it, you take the retained aggregates, wash them, dry them, and then accurately weigh them in grams. Okay, so how much ever is the loss by abrasion, is considered as the difference between original weight of the sample and that of the weight that is retained on a 1.7 mm sieve. Okay, and generally this is expressed in percentage weight of the original weight. Okay, so how will you get the formula or the abrasion? Let me write it for you so that it will be easy. Abrasion value will be equal to original weight minus weight retained on 1.76 mm sieve whole divided by the original weight into 100. This is how you will get it. Suppose it is a crushed gravel. So this is your final abrasion value. Only in case if you have a crushed gravel with you and you want to find the percentage of weight of crushed fragments, then the permissible percentage or wear is calculated using, so I'll write W. W is nothing but the wear or permissible percentage. Okay, so AL plus 100 minus A into L dash by 100. This is how you will get the value. Now, what are all this? This is your permissible percentage of wear, as I already told you. Next, A is the percentage of uncrushed fragments. Next, L. Here, L is nothing but the maximum percentage of wear that is permitted for a specific gravel consisting entirely of crushed fragments. Okay, so here entirely what will be there? Crushed, uncrushed fragments will be there. When you go to L dash, this is also the maximum percentage of wear, but here it consists completely of crushed fragments. Okay, so this is how you will calculate. What is this 100 minus A? This 100 minus A is the percentage of crushed fragments. So this is how you will go about with the devil's mission. Right, now next, if you are conducting the test of abrasion value using the Los Angeles mission, then it is slightly different. Now what are the abrasive charges here you use? Here the abrasive charges are slightly different when compared to your devil's mission. Okay, size is same but the number is different. Size same as devil's mission, for the number is different. So for the number, you have to refer to this table. You are going for grade A size of aggregates or grade B, grade C, depending upon this, it will vary. See here the number of spheres. There, for all the type, you are using what? 6 spheres, right, in the devils. But here you see 12, 11, 8, 6, 12, 12, 12. It is varying. And the weight of charge is also varying. There the weight of charge is fixed. How much was the weight of charge? Total weight? See, 2500 plus or minus 10 grams and it is always 6, but here the number is going to change. Obviously when the number are changing, the weight also will be changed. Okay, so 5000 plus or minus 25, like this for different number it will go on varying. Is it clear? So generally based on what is the grade of the aggregate which you are testing, based on that the abrasive charges will differ. So here also you will take the specimens or samples you can say, and oven dry them at around 100 to 110 degree centigrade. Again, you will place both the specimens or sample along with the abrasive charges in the Los Angeles testing machine, and you rotate it at a speed of 20 to 30 revolutions per minute. Now, how many revolution? It is little different. Suppose you are going for A, B, C, D, these 4 grades, you have to go for 500 revolutions. And suppose you are going for E, F, G, you have to go for 1000 revolutions. Okay. So the machine here is so designed that it will only maintain the proper revolution without any problem. So once this test is completed, you will remove it and then again weigh on the 1.70 mm sieve and take the retained values. You take this, wash them, dry them. Generally, the drying temperature in the oven should be 105 to 110 centigrade to have a constant weight. Okay, and you have to make sure that you weigh them in the nearest gram. After this, you have to use the same formula what you have used for Devil's machine to calculate the abrasion value. It is the original weight minus the weight retained on 1.75 mm sieve into 100 divided by the original weight. You have to use this same formula for calculating the abrasive value. Is it clear? So this is how you do it using the Los Angeles machine. Now let us go to the last test in the aggregates, that is the soundness test. So the samples of the fine aggregates for this test is passed through your 10 mm sieve and should be in such a size that it should not yield less than 100 grams of each of the below table. Okay, so everything should pass through 10 mm is sieve, but each of this criteria, that is passing through 600 micron and retained on 300 micron, this should not yield more than 100 grams. For everything it is the same. Means what? One category of size should not be more than 100 grams. That is what it means to say. Then what we will do from the coarse aggregate, the sizes, the fines which are finer than 4.75 mm are removed. This is from coarse aggregate. This is for fine aggregate. FA, you all know by now, it is fine aggregate. CA is nothing but coarse aggregate. And for coarse aggregate, this is what is the percentage we are having. So for between 10 to 4.75, 300 grams will be the maximum yield which you can give. And between 20 to 10,000 is the maximum yield. Here also we have two categories, 12.5 to 10 and 20 to 12.5. So here this should be 33% by weight and here it should be 67% by weight. Coming to 40 to 20, in this the division is again 25 to 20, 40 to 25. So here 33 and 67 and here the total yield is 1500. Like this for 63 to 40 and more than 80. So here the yield is 3000 each respectively. Okay, now what will we do? Suppose if it is in case of the fine aggregates, we have to thoroughly wash these fine aggregates. We have to make sure we place these fine aggregates on a 3000 micron sieve and then wash them. Right. After that, we have to dry them in the oven at around 105 to 110 centigrade. And then we have to separate them into these different sieves and test whether they are not exceeding the 100 gram each thing. Right. Now, what for coarse aggregate, what are we doing? For coarse aggregate, we wash the sample thoroughly. No need to put them in any micron sieve. You can directly wash them and then oven dry them at 105 to 110 centigrade and again separate them into different size according to this. And now what we have to do, suppose there are any particles which are more than 20 IS sieve, then you have to count them separately. Right. Now, what are we doing next? Whether it's coarse aggregate or fine aggregate, what we will do is we will immerse them in the solution of sodium sulfate or magnesium sulfate. Okay, for about 16 to 18 hours. And whenever we have immersed in this, we have to make sure that the temperature is of this solution is around 27 plus or minus 1 degree centigrade. Now, after we immerse it for 16 to 18 hours, we have to remove the aggregates and we have to drain this solution for about 15 plus or minus 5 minutes. Okay, so once we remove it, drain it, we have to oven dry the aggregates again at 105 to 110 degrees centigrade, and then the sample is allowed to cool at the room temperature. Now, this entire process we have to repeat multiple times. Now, how many times it is not specified or not specific. It depends upon the purchaser and the vendor on how you have to or how many times you have to do the test. Okay, then once we completely finish it, the sample will be examined for your quantitative and qualitative examination. Right, now what we do in that is, suppose you are going for a quantitative examination. So what we do here is, after the completion of the final cycle, the sample will be cooled and it will be washed thoroughly so that all your sodium sulfate or magnesium sulfate is removed out. Generally, we do the washing with the help of the barium chloride here, because this will try to eliminate all the solution of sulfate. Right, then we have to again dry it in the oven and weigh them. Right, if you are going for a fine aggregates, we will weigh them through the same sample of sieves which we have in this particular table. Right, if they are coarse aggregate, we have to follow this. So the size of the aggregates, if these are these, then the percentage of loss which we can get or in are 4, 8. The sieve numbers, these are 4, 8, 16 and 31.5. Right, then if we want to go for a qualitative examination, what we will do is, fractions of samples which are coarser than or greater than 20 are examined by immersing as well as completing the test. So we will observe and see that there are no disintegration, splitting, crumbling, cracking, flaking of aggregates. Okay, so this is how you do the soundness test. I hope all the tests on the aggregates are clear to you now. Thank you.